Beyond our sun lies a universe filled with dancing stars, locked in eternal cosmic partnerships. These binary systems tell incredible stories of stellar formation, dramatic orbits, and spectacular endings that shape our understanding of space. Let's explore how binary stars move together in space. It's like watching a beautiful dance in slow motion. These pairs of stars circle each other, pulled together by gravity's invisible force. Some stars spin close together, completing their orbit in just a few hours, while others take hundreds of years to make one loop around each other. The most common type we see are visual binaries, where we can actually spot both stars through telescopes. But there are also eclipsing binaries, where one star passes in front of the other from our view on Earth, creating a cosmic game of peekaboo. These dancing pairs aren't just pretty to look at. They help scientists figure out important things about stars, like how much they weigh and how bright they really are. Think of it as nature's perfect laboratory for studying stellar physics. Let's explore how these stellar pairs come to be. It all starts in massive clouds of gas and dust floating through space. As these clouds start to collapse under their own gravity, they often split into two separate clumps. Each clump continues to gather more material, growing denser and hotter until nuclear fusion kicks in. And boom, you've got two brand new stars. Sometimes the stars form really close together, almost touching, while other times they end up far apart, like distant cosmic neighbors. The amazing thing is that about half of all stars in our galaxy are born this way, with a companion. It's like nature has a soft spot for pairs. The process is a bit like watching two snowballs form side by side as they roll down a hill, each collecting more snow as they go. These newborn stars will spend their entire lives orbiting each other, bound by gravity's endless embrace. The force that keeps binary stars dancing together is gravity, the same force that keeps your feet on the ground, but on a massive scale. When two stars orbit each other, they create a delicate balance between gravity's pull and their motion through space. Each star feels a constant tug from its partner, like two figure skaters holding hands while spinning. The closer the stars are, the stronger their gravitational pull becomes. This creates different types of orbits. Some stars trace perfect circles around each other, while others follow stretched-out oval paths. The stars' sizes matter too. Bigger stars have stronger gravitational pull, like a big magnet compared to a small one. This cosmic dance can last billions of years, with the stars perfectly balanced in their eternal waltz through space. When stars pair up, they create some of the most beautiful sights in space, showing off different colors that tell us about their temperature and age. You might see a bright blue star dancing with an orange companion, or a yellow star circling with a red giant. The blue stars are the hottest, reaching temperatures over 20,000 degrees Celsius, while red stars are cooler at about 3,000 degrees. These color combinations aren't just pretty, they're like a cosmic photo album showing different stages of stellar life. Some pairs have one young, energetic star with an older, expanded companion. Others might feature two stars of the same age but different sizes. My favorite is when a bright white star pairs with a deep red companion. It's like watching a cosmic light show that can last millions of years. Now let's talk about the dramatic side of binary stars, when one star starts stealing material from its partner. Imagine two stars so close that one begins pulling away the outer layers of the other, like a cosmic vacuum cleaner. This happens when one star grows into a red giant, puffing up so much that its outer layers become loose. Its companion star's gravity then pulls this material away, creating a glowing stream of hot gas between them. This stellar theft can lead to amazing fireworks. Sometimes the stealing star gets so stuffed with stolen material that it explodes in a nova. These stealing binary stars, called mass transfer systems, help us understand how stars change over time. We can even spot them because they often flash brightly as the stolen material heats up while falling onto the thief star. The most fascinating part about binary stars is how their shared lives often end in spectacular ways. When one star starts running out of fuel, it can grow enormous, sometimes becoming so big it touches its companion. This close dance can lead to amazing outcomes. Sometimes they merge into one bigger star, while other times they might trigger massive explosions called supernovas. In really special cases, both stars might explode, lighting up their galaxy like cosmic fireworks. What's really cool is that these endings aren't just dramatic shows. They spread important elements like carbon and iron across space, which eventually become part of new stars, planets, and even life itself. It's like a cosmic recycling program where old stars help create the building blocks for new worlds. Not all binary star relationships last forever. Sometimes these cosmic pairs face dramatic endings that would make any soap opera jealous. When binary stars get too close, they might crash into each other in a spectacular merger, creating an explosion that outshines their entire galaxy. Other times, a passing star or massive space object can act like a cosmic homewrecker, pulling one star away from its partner. In rare cases, if one star explodes as a supernova, it might send its companion flying through space like a stellar fastball. These breakups spread star material across space, which is actually good news. This scattered material becomes the building blocks for new stars and planets. It's like the universe's way of saying, when one door closes, another opens. The most dramatic ending for binary stars happens when they create supernovas, massive explosions that can outshine entire galaxies. This usually starts when one star grows into a white dwarf and starts stealing material from its partner star. As the white dwarf gets greedier, pulling more and more material from its companion, it eventually reaches a breaking point. When it gets too heavy, about 1.4 times the mass of our Sun, the star can't hold itself together anymore. The result? A massive explosion that sends star stuff flying across space at millions of miles per hour. These explosions are so bright we can spot them from billions of light years away. The really cool part is that these supernovas create many of the elements we find on Earth, like iron in our blood and calcium in our bones. Let's zoom in on some of the most famous star couples in our cosmic neighborhood. First up is Sirius, the brightest star we see at night, which dances with a tiny but super dense white dwarf companion. Then there's Algol, nicknamed the Demon Star by ancient astronomers because it seems to wink at us every 3 days when one star blocks the other's light. We can't forget about Castor in the Gemini constellation. It's actually 3 pairs of stars, making it a cosmic family of 6. Alpha Centauri, our closest stellar neighbor, is another amazing example where 2 stars similar to our Sun orbit each other, with a smaller red dwarf tagging along. These stellar pairs have helped scientists understand how stars live, grow, and change over billions of years. Binary stars are like cosmic time machines, helping us peek into the future of our universe. These stellar pairs are perfect natural laboratories. Their interactions show us how stars age, how elements spread through space, and even help us measure distances in the cosmos. When we study how binary stars exchange material, it's like watching a preview of what might happen in other star systems millions of years from now. They've helped us discover that most stars prefer company, changing our view of the universe from a place of lonely stars to one filled with stellar partnerships. Thanks to advanced telescopes and computer models, we're now using binary stars to understand dark energy, test Einstein's theories, and even hunt for places where planets might form. It's amazing how these cosmic couples continue to teach us new things about our universe. Thanks for joining me on this journey through the fascinating world of binary stars. If you enjoyed learning about these cosmic dancers, hit that like button and subscribe for more space adventures. Share with your fellow stargazers.